he runs that program. Dr. Greaves is a well-known speaker in social semantic web. He speaks in Asia, Europe, and of course North America. And so I think we're really fortunate to have him here to give us a talk related to Semantic Wiki. And now welcome, Dr. Mark Greaves.
After an introduction like that, I hope I live up to it. I got like 4 hours of sleep last night. Carried a coffee. So what I thought I'd do, actually I had this whole talk planned out about a week ago, and I was going to really concentrate on the linked data work that we're very interested in Vulcan, and in particular in setting it in the context of a lot of the work that we had done this year with Enterprise and other partners on making SMW, building extensions for SMW so that it would play better in systems which had multiple databases, multiple sources of information, where you couldn't sort of own all the information inside the wiki, but needed to play in a much more enterprise or government context. And then, of course, there were 2 excellent presentations on that yesterday, and so I had to revise a bunch of stuff. And so what I'm going to do in this presentation, and it's Saturday morning, and so what I thought I'd do is talk a little bit more about this project, which Jesse mentioned, called Project Halo, which is where did that come from? How does SMW fit into this? How is Vulcan, which is this kind of obscure, intentionally very low-profile company in Seattle, Washington? How is it that we're involved in this? Why would which we call the digital Aristotle. So if you think about the digital Aristotle, this is think about the historical figure of Aristotle. Aristotle was probably the last person, at least in Western civilization, to have made a plausible claim of knowing everything that there was to know, right? He was the tutor of Alexander the Great. He probably had, for the Greek world at that time, a grasp of almost all of the technical knowledge. I mean, think about that. Think about actually having that one break. Never happened again, right? Knowledge just exploded, right? And so, so then for what, 2 millennia, we got sort of more and more fragmented, And, Paul started thinking, and he started thinking about this a long time ago, like 30 years ago. It's like, why is it that, 30 years ago, big IBM computers and the PC revolution and so forth, why is it that computers can't just hold this vast amount of information? We can ask questions and get an answer. I mean, it's a pretty simple thing, right? We should be able to talk to our computers and get an answer. And so he sort of formulated this vision about, well, let's call it the digital Aristotle, the new Aristotle for the 21st century, that would hold a vast amount of what the knowledge he's interested in is scientific knowledge, and then answer questions based on that knowledge. Not do what Google does and the search engines where give you, possibly relevant documents by the hundreds, but actually, if I ask, a direct question, is the number of chromosomes in a pine tree greater than the number of chromosomes in a beetle, right? I could get an answer, yes or no. And so he believes that such a thing would dramatically accelerate scientific progress. I believe that too. I think it's actually just intuitively obvious. I don't think it bears a lot of argument. And so, back in the early part of this decade, or last decade, he started thinking, well, why don't we actually try and do something about this, right? Why don't we build it? I mean, the World Wide Web is coming online, all this stuff's coming online. Why don't we build it? And so we came up with a list of requirements for it. And you look at those, and they're not, all that surprising. So Project Halo became this project which Jesse mentioned, became this programmatic instantiation of those goals, right? A specific program to execute on some of those goals. And for those of you who know about public sector funding, it's very similar to a European Commission integrated project or a project that's funded by DARPA in the US, DARPA being an organization I used to work for. So what do? We we actually look very similar to a DARPA project. We coordinate with some other efforts in this area that are worldwide. But we have a philosophy of not trying to build, all of the digital Aristotle, Project Halo stuff in an office building in Seattle, Washington with people who we can lure to come to work for us in Seattle, Washington, but to really go out and find the best teams, the best people, the best ideas worldwide, and fund them, as fire hose money into them to change the world. So this is sort of my job, right, is to go out, find those people, find those ideas, find those capabilities out there which, if they got put together with a couple of other things, could really make a difference and really accelerate stuff, and really try and create change around that. So we have 3 thrusts in Project Halo. The major one is what I've taken to call textbooks you can talk to. And so I'll show you a little bit about that because I think it's really quite exciting, and we'll show you where the digital Aristotle fits in this. Actually, why don't we do that now? So this is something which we're building right now in the project. And you can think about it like, so think about the role of the calculator in the teaching of mathematics at the high school level and below, right? Even the college level. Calculator completely revolutionized. I have 2 children, one in elementary school, one in middle school. Even the textbooks assume that there's calculators out there. And the advent of the graphing calculator completely changed the teaching of calculus. When I took calculus, I had to work for 20 minutes, 25 minutes to plot, 5 points across a derivative and then do the graph and sort of hope that I didn't miss anything in these 5 points. Now you just punch it in, and all of a sudden you've got the graph, you've got the solution, you can do everything. So, completely revolutionary for mathematics. What is the equivalent of a calculator for biology? What would be that revolutionary box? And I assert that it's a textbook you can talk to, right? That it's an electronic textbook which you can ask a question to about biology, maybe this chromosome question I just had, and get an answer, right? Maybe you speak to it, maybe you type it in, maybe you speak in your own language, or you speak in a different language, and it comes back, and there's all kinds of variations you can do on that. That's what we're building. Okay, we're working with textbook publishers and so forth to actually try and build this. Turns out it's very hard. We may succeed, we may not succeed. There's a lot of reasons why it hasn't been built before. But we're making an effort at that. So we've got an iPad app which we call Inquire. And we've got a server in the back end which runs a formal knowledge base, right, which is coded directly from right now the most popular book on biology in high school in America, which is the Campbell and Reese biology book published by Pearson. And interprets questions, answers questions, and so forth. So it actually looks like this, right? I'll take you through a couple of real quick slides on it because it's pretty cool. You can't buy this; this is all internal, but it contains the content of the book. We have sort of all the usual e-reader stuff on it. I'm not going to go through that part of it. But this is an example of sort of looking at the knowledge base in there. So this is some of the things which, at least in, I think this was probably taken in September or October, some of the things we knew about proteins. So we know a great deal about proteins, but in the knowledge base. But what are the parts of proteins? What are the kinds? What are some pictures about proteins and so forth? So if you have if you sort of type on the word protein, you get not just a glossary entry, but really a view into the knowledge base, which you can pivot around on. Plus we can do these things called concept maps, which if you've been in schools lately, these are completely ubiquitous, and there's a lot of educational research that says that there are many people who respond better to graphics like these than graphics, than sort of long descriptions of stuff. They like sort of navigating through big graphics about proteins. And so this is an example of, as I say, protein, and it's got some ISA relations and some partonomic relations, past part of relations. There's tons of other stuff we know about this, but that's an example of the kind of stuff. But then, of course, we can move on to question answering against those knowledge bases. So one of the things that we do is we can take a sort of swipe through text of the book, and just start generating questions that we can answer based on that. So all of a sudden you've got automatic custom review questions, right, which you can look at in this. So this is, in this case, we just took one sentence off of this paragraph, and now we start asking about, well, does the student know what active transport is? Do they know what the difference between active transport and facilitated diffusion is? And so forth. And each of these things, you can click on it, you can get an answer, and it kind of looks like this, right? This is the active transport and passive transport window. But not only can you do this, you can look at other questions, or you can even freeform it, you know, and say, so now the question is, what's the difference? And well, what's the similarities between active and passive transport? And you can also get answers. In this case, the answer is pretty primitive. Whenever the screenshot was taken, I looked at it. And, well, it says, well, they're both a kind of event, and there's a, moves from high concentration to low concentration. So that's not the important part. But you can sort of see we're getting better at that quite substantially. You can sort of see the vision, right? And so that's one of the things that we're trying to build. We think about how is it that we can get to the digital Aristotle. So we got that. We've got a whole bunch of sort of fundamental research and development on new directions in knowledge representation. How do you build these knowledge bases and reason with them underneath? And it turns out that and this is where we get back to SMW, one of the most costly and historically ineffective parts of artificial intelligence, right, of this sort, has been getting the knowledge into the system, right? Just teaching the system the things which takes humans years and years to figure out. This is historically an unscalable problem. We did some measurements at Vulcan to even take primitive, this back in 2004 or so, 2005, to even take primitive knowledge from a biology textbook and encode it into a system was costing us order of $10,000 per page, right, from a high school level textbook. And we had, good scale in there. We didn't have any reason to believe that was an unreasonable number. And if you've ever seen biology textbooks now, they weigh in at about 1,000 pages. But sort of more importantly, so we had to address this, we had to develop all the processes for quality control and checking and how do you do joint stuff, and how do you make knowledge entry not the province of logicians, but really subject matter experts, people who actually know biology as opposed to who know coding systems. So that's how we stumbled into wikis, right? Project Halo challenges about the digital Aristotle were really about knowledge formulation, question formulation, and question answering. They're these three big R&D areas. But if you look at knowledge formulations, how do we create these giant ones, these giant knowledge bases that you need to actually think about a knowledge base that could answer, let's say, they could score a 5 on the AP test. And all of a sudden, we sort of ran into this work. This would have been about 2006, I think, that Marcus and Denny had done on, crowdsourcing information, right, with semantic wikis. They had coined this term, semantic wikis, and I thought, that's really interesting, right? That is, in fact, so interesting that I want to be in there. And so if we saw some possibilities in here, right, that you could have this kind of socially driven, low cost, really not really around databases, but around maybe less structured information, knowledge acquisition for AI, that data integration was this huge bugaboo, of course, right, that we could maybe do this on what is now called a pay-as-you-go basis by people like a lot of people. And we could deal with change maybe a little better this way, right? So change is, again, this horrible problem. And so maybe we can deal with evolving schemas this way, because these systems seem to be schema-lapsed as opposed to schema-first. Right? The first thing you do in a database is design the schema, right? Which is usually the first place you go wrong. But these things were schema-lapsed, so we like that. So in 2007, we looked around for a small development team that could improve SMW. SMW was, at that time, pretty much an academic project. And we found Enterprise, so that's the sort of root of a lot of their involvement here. And we wanted them to just kind of bridge between this piece of code which Denny and Marcus had written, which was, I think, a proof of concept, but it was actually pretty hard to actually use. and something which we could use to test with in Project Head. We're thinking a lot bigger than that. But we wanted to have a system where the markup tools didn't require people to actually know the wiki markup, because that was a big barrier. We wanted to have some tools which kind of promoted similarity of markup across different authors. We wanted a visual query builder because people didn't want to learn Ask. Even something like Ask was too big of a barrier. We wanted some kind of data structure browser, and that became the ontology browser. So we did some, and so they built this actually very quickly and very nicely. And well, we decided it was all going to be open source. Actually, forced to by the license, but we've probably done it anyway. And the results were pretty promising, and I'll show you some of the old results from that. This is an old chart. Daniel's probably shivering at it. This was a long time ago, probably 2007, 2008, I think, was about when we did this. So we took a bunch of graduate students. We stocked up a wiki with some about 700 pages in chemistry, and we took some chemistry graduate students and paid them to try and annotate. Just go and annotate stuff, right? Let's see what kind of annotations you come up with. The initial results were really, really disappointing, right? People had, we ended up with a lot more pages. Went up by, sort of inflated by about 50%. Had about 5 assertions per entry, but they were completely bizarre attributes. People didn't coordinate very well in the early semantic wikis, and they'd have these attributes, these long predicates, properties like, has a pH value of 9.5 when mixed with an acid, right? That's a property of something. What are you going to do with that? And so we built, so that was a sort of initial result. It's like, oh, this whole experiment's not going to work at all. And then we started building some gardening systems and some systems that, as I say, promote semantic coherence, promote agreement between things like property labels and so forth. And things got much better. And this chart that's up there, which, I'm not going to really explain, but the key is that it goes down, right, is sort of the number of errors which we saw over a period. And we saw people actually converging, not completely, but converging on a set of common labels. And, one of the things we also found was that, these things tend to contain a lot of garbage. It's, 10% of abandoned properties and things like that that didn't, never seemed to work. And always some level of noise in there. But I like that, I think that there's the root of a lot of evil in databases is the pursuit of perfection, right, at the expense of the good. And so we built some extensions, the early gardening extensions. We did some system usability testing, and we looked great. It started to look much better, and so we continued on that. And we learned some lessons. This is actually an old chart too, but I still, and so I pulled it out, but I still like it, right? And you look at this, and it's like, oh, this is obvious. But in 2008, it wasn't so obvious, right? That user interface design, of course, and this time they had their old skin, their monobook skin. We did a lot of formal usability testing. I think the real key was gardening matters, right? You needed to have, even in these early wikis, you needed to have somebody who was looking over the semantic work a little bit. We did find that user-created ontologies were not what logicians would build. They tended to be very flat, right? Not a lot of class hierarchies, but a lot of breadth. So as I say, flatter than normal, also extraordinarily cheaper than normal, so we like that. And that wikis were actually, again, this seems obvious, wasn't obvious at the time, or at least we convinced ourselves that we needed an argument for it, that you needed to have something to augment the bare semantics, right? And the way that wikis combine structured and unstructured information, that is, we have markup that is in the page, right? And the page also has language on it that can be used to explain things that you can't capture in the markup, what exactly these properties mean, and just express things. That really made a huge, huge difference. So these lessons sort of convinced us to go back to the semantic rules and to continue to support them. And so by 2011, I think we're sort of a main player. There's other players too, of course. But we're a main player in actually a really satisfyingly growing community. For us, our focus has been guided by Mr. Allen. He said, well, let's take the software and let's see if we can make it better, at least more commercially better, because that's going to help everybody. And it's the kind of expensive stuff that is hard to do just by one or two people working alone. And so our focus, Vulcan's focus, has been on requirements that drive out of the AI use case, but for the enterprise or commercial market. So we have all this stuff that you've sort of seen, over the years, and a lot of stuff we've done today, or this year. We have some nice community forum stuff, although it was, for the very first time, unexpectedly down in the United States. We had a power surge in our hosting provider. We've had user group meetings and a much expanded team from a fairly small enterprise team. Now we've got enterprise has actually been joined by several other contractors, named from China. We're international. Actually, I should mention the whole Project Halo team's international. We have contractors in India, Europe, and all over the world. And I think the bottom line is that really, if you're looking for a piece of software supports large-scale community-based knowledge acquisition, right, in a computer processable way, this is your option. There's almost nothing else that I can think of that would, you could make some kind of custom SharePoint thing. But if you're looking for something that actually has been proven to scale, right, this is it. So I'm real pleased with this. And so is our sponsor. So some developments over the last year. Just since I look at these numbers every month at least, but y'all may not have seen them. So for I don't actually track SMW itself, but for SMW Plus, right, this sequence of this package of extensions, which Enterprise has, we run about 2,000 downloads a month off the source for it. You can get it from GitHub and Google Code as well. We have good solid commercial support from Enterprise, a number of commercial customers. The traffic on our SMW forum runs about 8,000 visitors a month, about 5,000 uniques, so we like that too. That's looking good. I will give a shout out to Will for our completely vastly improved SEO on this. We're now showing up on the top 10 results in Google. And we have, mirrored it. It used to be the SMW forum, took 20 seconds to load if you were on this side of the Atlantic, since it was hosted, I believe it was hosted on a computer under somebody's desk at Enterprise. But maybe not quite. But, anyway, so we've got some nice load balancing and caching going on that, and we had a 5x. Should see response times in the 2 or 3 second level. Last year, we had this sort of whole exercise of, well, what do our customers want in SMW? Because it was looking pretty good. And we came up with really 4 areas. One was security, so we worked hard on that. One was, even though we thought authoring was easy, we were wrong. And so, in fact, the #1 download from the SMW forum right now is the WYSIWYG editor. Right? That's the #1 thing, is that people still think that, I think for good reasons, that the MediaWiki editor is not usable. What I've been told is what people really want to do is edit in Microsoft Word. Right? That's what they want. That's what they know, that's what they want. So we worked on semantic forms, a much better autocomplete, all this stuff which you've seen. We worked hard on external data support because as one of our customers told us, SMW wants to be the center of the universe. Right? It wants to hold all the ontologies and all the data together. And that just does not cut it in a modern environment. And so we worked really hard on that, and also on the deployment framework and so on. And really what's happened is SMW has gone beyond sort of what I think of it as a knowledge acquisition system and turned into a platform. So, so what are we going to do in 2011? Well, we've got some, this accounts for, let's say about half of the Vulcan-sponsored team's workload in 2011. And it's what I call the sustainment parts of this. So there's been a persistent, this is not everything, these are just, I've just picked out some of the major stuff. There's been a persistent question about how you do refactoring of the data in SMW. People will build ontologies and then they'll want to, go through and rename properties all at once, or rename properties just out of subsets of instances. They want to be able to modify a ton of property values all at once rather than going to every little page and doing things. I want to have, so there's a whole bunch of kind of data refactoring that we've got to work package on. We've got some kind of cleanup, consolidation stuff. Michael mentioned the multi-ontology stuff yesterday, where we're not going to be, we've got some limitations that are imposed by SMW itself, but or by MediaWiki itself, really. But we're going to make a stab at that. We're going to make a stab at making these components extensible, so that you can actually have an API to go in there and extend them. So there's a lot of, if you look at the code, there's update mechanisms are kind of scattered across the system, and so there's some cleanup there. The usual sort of stack of improving things that annoy us, and hopefully some continued great community support. So that's what I'll call the sustainment work. Really, the major thrust is kind of what titled this talk, which is SMW and linked data. So this is the obligatory linked data cloud. It's supposed to impress everybody. But linked data is really, really impressive. I mean, there's a lot of data out there. It's of widely varied quality, but but there is a tremendous amount of data published on the web with these linked data philosophies, the 4 linked data principles published in RDF. And what we think, is that SMW is actually positioned to be a browser curation publication platform for linked data. If you look at the browsers for linked data that are out there right now, there are things like Marbles and whatnot, if you've seen these. They don't look slick, right? They are daunting for somebody who's not a computer science graduate student or somehow otherwise externally motivated to get at this stuff. And so I think SMW really is positioned to play a role here, and I'll say also a commercially interesting role. Because anytime I see that amount of data, even of quality, which is better in some places, much better than others, I think there's a role to mediate in there. There's a role to expose this and to use this to accelerate commerce. And so, even though SMW is free, I think that there's some opportunities here too. And so we look at that and go, well, what would we need to do? So the current situation is that we do have a pipeline that looks like an ETL system. Extract, translate, load. Standard corporate data integration. It's been in SMW since 1.5.2, so that was, I guess, first release in December, Daniel?
In December.
Yeah, it was December. And we have something called the linked data extension, which you can go download. It's still, it would be difficult to use without some support from us, right? But it was our first effort as we threw it out there. And we had a particular use case in mind in Vulcan, which I will get to in a minute, but it's the kind of usual ETL pipeline, right? It supports this workflow, where you load, the idea is you're going to load a bunch of external data into a triple store that is connected to the wiki through the triple store connector, and then 2 pieces of technology that came from the Free University of Berlin. That's the linked data group there, Chris Bitzer's group. One called R2R, which many of you are probably familiar with. That's a schema mapping language, and one called SILT, which is a set of rules and actually really kind of interesting general system, which will allow you to take 2 of the same entity, which are referred to differently across databases, right? So maybe you've got a gene which has got 2 names, right? Name 1 and one names one the other one. And try to apply some heuristics on that. And then you jam everything in locally. And we also had a trust system on there, so you could say, well, if I need some biology data, I'm interested in going to, I think Uniprot is the, let's say, the authoritative database on proteins. And so that if I need protein data, I'm going to get it connected. And so we have this kind of pipeline of import, map, resolve, store, and reconcile. And that's what 1.5.2 in the linked data extension does now. So what would our goals be in 2011? So first we got to improve that current pipeline, because we actually have a use case that I'm going to talk about in a little bit. And so we're going to, as it happens, that pipeline looks very good on paper, but as it turned out, it wasn't very fast. And so, so we're going to essentially take the Silk and R2R pieces on that and put them on Hadoop. So we've got to, as it turns out, this process is actually embarrassingly parallel, so it does fit on a parallel environment like Hadoop. Right now, on an Amazon M2 extra large, it takes almost 19 hours to do that kind of thing, and that's combine that with a lack of debugging tools, so it takes 19 hours to figure out you've dropped a comma somewhere, is not very good. Yeah, that's what we found. We absolutely found that. And so also, so we want to improve performance, we want to improve the transparency, because the whole idea of a wiki is to put many eyeballs on a particular thing. And if you're thinking about data integration, you got to think not just about the data, but also about the mapping rules, about the schema, and the policies and things like that. So trying to put these artifacts as wiki elements, and also to a certain extent be able to change them, or at least propose new ones in the wiki. The most dramatic thing we want to do, though, is really break that ETL loop apart and start thinking about federation. And I mentioned this yesterday. So we want to access linked data essentially without loading, right? So that means send Sparkle queries to any endpoint, which means federated query. And so, notoriously hard problem, but we've got some things which we're going to do, and hopefully 2011 we're going to have 2 different options which we complete. So one is one free option based on Arc and Jetta, right? And one licensed, more high-performance option, which actually you saw some pieces of yesterday based on Onto and so it'll also going to require doing things like specifying endpoints in the query interface. Again, this aligns very well with the SMW should not always be the center of the universe problem. So here's an example of how we're going to do this with OntoBroker. This is a sort of boxes and lines diagram, but it shows you pretty well. So you have the wiki on the top, and then we've got, this is a blow up of the triple store connector, which is the way in which we hold a lot of triple data and interface it into the wiki and make it complementary to the explicit markup which lives on the page. And so there's triple store connector, which handles query in this case, and then inside the triple store connector we've got the ability to use OntoBroker in this case, which is a reasoner, which will then allow us to figure out, okay, if we've got 5 data sources, how are we going to split the Sparkle queries between them? How are we going to fail over between them? How are we going to do all the mappings? How are we going to do the lifting of the ontology into the graph? It's a really nice package. It was kind of developed a lot for that use case. And so, so that's easy for us, relatively cheap to do, and it provides a nice supported environment with all those funny great graphic stuff that you saw Michael demonstrating yesterday with the drag and drop mapping rules, and take one class and split it and send it into 2 classes and so forth. It's really quite nice stuff. The Arc versions are quite a bit simpler, and so we're actually going to delay this as much as we can to give this opportunity to mature. You have to do things like use the service clause on Sparkle 1.1, which means that you've got to specifically say where the data is coming from. And you don't really have the same kind of lifting capability, so you typically have to use the schemas and the target data sets. But it will get the job done. And so, so that's right now our best option for a free option, although, love to hear some discussion. So the current programmatics look like this, and there's a big disclaimer up at the top, right, which is that I am the program manager, so we get to change things whenever we feel like it. But this is this is right now the plan. That we'll have 4 releases of SMW Plus over the next 12 months. The first release will happen about 2.5 months from now. It'll have some of the multiple ontology support, more improvements to the deployment framework, some of the ways we can handle the linked data artifacts that I mentioned earlier in the wiki markup, and some work in Silk. There's also a lot of infrastructure work that's going to be going on at this time to try and set things in place for release 2, which will be mid-September, plan right now, with the really start bringing Sparkle in the query interface, this kind of notion of what we call a data access project, which is a big grouping of data sources and data access methods, ways to model the mappings, and the OntoBroker-based federated query. So that should be coming in September right now. By the end of the year, for Christmas, we're going to start bringing in the refactoring tools, more on the linked data artifacts, lifting it into the wiki. Remote Sparkle endpoints and Hadoop should come online about then. if you have a need for this, we could probably squeeze it out a little bit earlier. There's already been some work on this, but right now that's where it's slotted, just in terms of trying to level load all the labor and things like that. And in release 4, by mid-February, we'll have the extensions and the ARC stuff. So why are we, so now I'm going to sort of come back. So why are we interested in this? Why is Vulcan interested? Well, one of the things that we're trying to do, remember, so our goals are these big knowledge bases. Right? That's what our sponsor, that's what Mr. Allen is really interested in. And trying to solve the hard problems that are around the construction of those knowledge bases. So we want to do something, I think, not a surprise to many people, especially since he's been talking about it recently, that Paul is a major funder of neuroscience research, right? And has built something called the Allen Institute for Brain Science, which is this, I think, amazing place that combines hardcore neuroscience with hardcore data processing, right? It's really interesting. I won't describe what they do, but it's essentially they're producing data sets in neuroscience that have never been produced before, that are, you know, at the terabyte scale, that are medically interesting, really cool stuff. And so one of the things Paul's been thinking about is how can we use, you know, all these information technologies to accelerate progress in neuroscience. And one of the things he asked us to do is to explore the notion of what would it be like to have a wiki that would have all neuroscience data in it at a high quality scientific level. So not just Wikipedia, but something really much more high quality than that. And in fact, why don't we not make it like a traditional wiki, but why don't we make it more like a data wiki? Because just like physics, just like chemistry, biology, particularly neuroscience, is becoming a data-driven science these days. There's a data-driven science without a lot of the data-driven tool support, and so maybe there's something really interesting here, so why don't we start prototyping? So we've been working on that with SMW, and essentially, so this is one of the reasons why we're in linked data, is we've taken a bunch of data sources which are in linked data formats from BioRDF, linked open drug data. There's a number of these that are out there on the web, and built this ETL platform. We took some actual, real data sources and have been querying them. Michael actually wrote a neuroscience wiki ontology at one point last year.
The layman's version.
Layman's version. Yeah, well, it did not survive contact with the Allen Institute, but
We can simplify that more.
yeah, but you know, we gave it a try. And so we're going to evaluate. So we're building this prototype. We're going to evaluate it in June. And so you're going to have pages that look kind of like this, kind of like Wikipedia, but really a lot of neuroscience data in there, custom queries, things of this nature. And again, this kind of pay-as-you-go style of data integration, which is, I think, the only way to economically, feasibly integrate neuroscience data. So coming back to Project Halo and the digital Aristotle, right? Some people sometimes ask me, so, you know, is Vulcan just going to shift out of this, right? Because we spend some money in this community. I think, you know, we are committed to the success of SMW. We think it really aligns well with our goals about lowering the cost of knowledge authoring on the web, getting an ever-increasing amount of the world's data online. It is a very nice complement to this textbook work, which I showed you earlier. The textbook work, very curated data, very tied to the book, right? But for example, a biologist friend of mine said, you can tell how recent a book is in biology by how many genes it mentions. Right? And these books revise at the regular textbook level of, you know, once every 4 or 5 years. Right? There's a lot that happens. And so we want to be able to complement that kind of textbook-rooted knowledge with other knowledge sources. So we are committed. We're pretty excited about it. We think it's a lever which, you know, could move the world, and fits well with our vision. Let me wrap up. We have a discussion at 3:15. I think pretty brief, but kind of traditionally, what we often do in these users group meetings is try and understand. You know, we've got some programmatics, we've got some stuff on the table, but are we going in the right direction? Are there things that SMW as a community needs? Things that we can help with, things that the community can help with, and in particular for this kind of enterprise and government style of requirements. So, multi-database obviously came out of that. A lot of questions still around usability. Have we achieved something which is deployable in the enterprise or not yet? We have a level of security. I asked about that earlier. Is it sufficient? Right? Maybe not sufficient for, extreme U.S. government kinds of applications, but is it sufficient in the enterprise? Or is it sufficient if you install it, as I think Mike suggested, maybe behind, or maybe Ian, maybe it was you, right? Behind, you have a system which is reasonably secure, but you put it behind a great big firewall, and you figure the combination is okay. And of course, anybody who's in this business has to look at your competition, right? SharePoint, obviously, wikis like Confluence, people like Z-Agile who are out there selling semantic plugins for Confluence. Where are we strong? Where's our competition weakest? Right, so targets of opportunity. Where are we weakest? Where are the things we got to work on? So these are some questions which I'd like to talk about. Let's see. Around 3:15, we've got a half an hour. Take real good detailed notes on this. I will. And I think with that, I will thank you very much. It's great to see y'all. Time for a couple of questions, if there are any. Otherwise,
this is sort of a kind of an open-ended question, but you're talking about neuroscience research and improving health. I guess is the general sort of vision, which is an essentially altruistic kind of goal. But you also mentioned looking for ways to corporate involvement and looking for money-making opportunities. I guess was some
Sure.
subtext.
Sure.
So how important is making money and making a profit from this project?
All of our work in this project, not all of it, 90% of our work, right, has been open source, and we are committed to breadth in that. So a lot of our work is committed to that. We believe, though, that the way you change the world, right, or one of the ways that you change the world, probably the likeliest way to change the world, is to build a great company, which has the scale, the agility, the customer focus, right, to go out there and penetrate the economic systems of the world. So we are not right now collecting any IP on this, but we have always been interested in that route of impact. One of the great things about working at Vulcan is that not only do we have the joy of watching the Trailblazers, the heartbreak of watching the Seattle Seahawks, and you can feel some ownership of that when you're at Vulcan, because one of Mr. Allen's passions, activities, investments. But we also have a venture capital organization where we invest in things. And so right now, we're always keeping our eye out to look for opportunities where sufficiently motivated people with the right team and the right idea, who just don't have access to capital, but if they had access to capital, they have a good bet, right, to change the world. So we're always looking for that. And, should people in this room, right, say, what, we've been messing around with this, but I have this great idea. We're going to take SMW and use it for, I don't know, the next Facebook, right? Or the next, that's sort of high bar. But the next iteration of Wikipedia, the next iteration of semantic advertising, the next iteration of a corporate internal knowledge base, the next iteration of business intelligence. We've got a niche, we've got a customer focus, we've got an idea, we've got the software, and we want to run for it. Absolutely, talk to me. Because that's what I mean when I say that we're on the lookout for commercial opportunities. Vulcan itself, our ability to do this that's not where we want to be. But we want to participate in, share in, and fund the success of others. Does that answer your question?
Yes, although it brought up a follow-up question, but
Follow-up.
okay. Well, yeah, I was surprised that you said the word IP, actually, because the words Paul Allen and IP together is a combination that's dicey in some people's minds, or in some circles. So I don't know if you wanted to say anything about that in the context.
I think, well, so I actually reject that characterization. I mean, I think that, I assume you're talking about the interval stuff?
Yeah.
Yeah. So, Paul Allen spends $100 million on a state-of-the-art computer science research group, get some of the smartest people in the world together. Some of those people do things like fund other people, like Google, right? Like Larry and Sergey when they were in graduate students at Stanford. In fact, if you look at their famous paper, you know, what is it, Design of a Search Engine or something, you look down, you know, who funded the work in this paper when they're graduate students? We've got DARPA, we've got the National Science Foundation, we've got Interval Research. Some people at Interval Research were, in fact, good enough thinkers that they came up with some patents, right? Patentable ideas. They filed, USPTO granted them. Now it looks like those patents are worth a lot of money. So Paul's looking at that. But in this area, right, you know, we have not filed any IP, right? We have not filed patents. The things that we do that aren't fully open typically have a lot to do with details around enterprises, you know, commercial software, which is just not appropriate to make open, right? But it's not the sort of core of SMW. And our track right now, and that's what the boss tells me, and our track right now is for impact and adoption. Right? That's our philosophy. Sure.
I still remember it.
I give long answers, sorry.
Could you come back to me?
I can, or maybe we should do it at the break.
Competition was a surprising word for me.
Competition.
Competition was
you mean as in the competition for SMW?
Confluence, and one more was mentioned. SharePoint. I think of these as really being narrow competition on the wiki part, but you're trying to do a lot of other stuff. And I'm wondering if competition exists in that broader space.
Oh, sure. Yeah, I just use those as examples. It's not meant to be exhaustive. I mean, SharePoint is a platform, right, and has a wiki instantiation to it. You know, I think of, and certainly when you go out to companies, right, including Vulcan, by the way, we had some internal projects, and the question was, well, should we use SMW or should we use SharePoint? Because we got a bunch of guys here who already know how to use SharePoint. So that's why I threw them in there. Confluence, of course, because they're, you know, most popular commercial wiki. But no, I think that you could certainly expand the notion of competition and the notion of what platforms can to include things like Drupal, you know, the whole CMS space. But if I got your question right, I didn't mean that to be exhaustive. So there's a bunch of things I track.
I'm still a little surprised that competition is defined in terms of different code bases rather than different enterprise or other companies or other efforts like this.
Now I see your question. No, I think of it. I really do think about it in terms of products. You know, Vulcan made choice a while ago, 4 years ago, to fund Enterprise doing this. You know, they're a great team. We're real pleased with them. But you know, we've been very careful to say that, you know, we don't, by working with Enterprise, we don't stop working with anybody else, right? We don't, you know, try and squash corporate competition for Enterprise. That's not what we're about, right? You know, we're just about getting it out there. And so that's why I think competition really in terms of product as opposed to organization.
Yeah, I know one thing that we have kind of, not me, but other people have kind of looked, because we have several wikis and think about, is wiki really the thing that we should be using? You know, Drupal was brought up when you mentioned Drupal.
Sure.
So there are people, I mean, that is one of the things they would jump out of the wiki and go into somewhere else.
Sure.
They thought about that all the time, but now they're actually actively, not that there's any limitations, they just want to make sure.
Yeah, no, and I think that's right. I mean, look, Drupal has no write book. We don't. Yeah, I mean, it's all. Well, the SMW doesn't.
Oh, not SMW.
Yeah, and the sort of the mind share footprint pretty big in some of these things. So I think about that. If our goal is spread adoption, larger amount of the world's knowledge online, and this whole thing, how does SMW fit in that ecosystem, and how can we make it grow? Michael.
Yeah, my question would go back to the digital aerospace.
Mm-hmm.
Can you say something about the competition with IBM?
Yeah, I can.
Maybe over the coffee then.
Yeah, maybe over coffee. Yeah. I'm sorry?
Turn off the videotape while you come in.
Turn off the off the record. IBM's Watson was an unbelievably amazing achievement. It is something which we certainly looked at DARPA right around the time IBM was looking at, and so 5, 6 years ago, right? And said, no way, no way, right? Way too far. And so it's a huge compliment to the IBM team that they did it. They have some really fascinating new techniques in particular evidence weighing, right, and parallel work. Great job. Hats off to them. I think that the digital Aristotle, though, is aimed at a different place. Right? It's easy to confuse the two places, but the digital Aristotle is really aimed at a different place. And the way I'll say that is that Jeopardy questions tend to be factoid-style questions. Right? And so it's looking up the factoid. Right? And for a computer, it's actually really fascinating. Right? For a computer, the really hard trick is understanding the question. Right? Once I understand the question, I get the factoid in a millisecond. Right? But it's really hard to understand the question. That's actually the complete opposite of a human. Right? Who understands the question immediately, right? And then has to spend their time trying to think if they really know it or not. But it's really these kind of factoid questions. And that's built into the structure of the game. The digital Aristotle is really aimed at things that are not factoid questions. Show me the similarities and differences between these two biological structures, right? Is the following, a plausible cause of something else? Right? What happens in mitosis if stage 3 is chemically interrupted? Right? Things like that, which are different. So we're going after a different area. That having been said, it's clear that the digital Aristotle is going to look like a hybrid of technologies. That is absolutely clear.
The difference also is that Watson is using NLP for understanding the text, and in digital Aristotle, this is not the case.
No, so Watson has a ton of curated databases in it. Right? They're not sort of reading Wikipedia or CIA World Factbook or something like that and trying to use that as the basis for their answers. They got a lot of explicit, curated, traditional databases in there. And of course, they've got some other things, where let's look up sentences, see if we can find evidence for things. But and they've got an unbelievably clever NLP front end, right, which has to do with all these parallel, let's try and figure out what the questions trying to ask, right? Really clever work out there. But sort of as a knowledge representation strategy underneath, it's not all NLP. Right? I'll put some asterisks by that, and we can talk later. But the other thing, if y'all don't know what we're talking about, right? That means if you're in AI, you've been under a rock. But if you're, but if y'all don't know what we're talking about, IBM, just completely kicked ass on a problem that was thought to be way beyond the scope, which is the playing of the game show Jeopardy, and really unbelievable. I think I gotta go, but thank y'all very much.
I think it's fast. Yeah. It is fast. This is 2.5, 3 years ago. It's amazing. But